Assalamualaikum and good morning. We are from RK20 Computer Engineering. Will present question number 4, Planet Exploration System. The group members are NUR'AIN HUSNA, NURFADZILAH AQILAH, NUR'AIN NAJIHAH, and me, SITI Nurliza. Introduction. Planet exploration is when scientists recognize that spacecraft could gather valuable data about the various planets. Control engineers play an important role in the success of the planetary exploration program. As flight computer hardware and operating system improve, the role of autonomous vehicle spacecraft control system will continue to increase. Objective. First, to draw the plot of the system and determine the gain and the phase margin of the system. Next, to design a capacitor, lead or lag, so that the phase margin will be at least 45 degrees.
Assalamualaikum. My name is NUR'AIN HUSNA and about planet exploration system, an unmanned planet exploration system which require a high level of automatic control is shown using a block diagram in figure 4. Given the block diagram, amplifier and actuator, the equation for amplifier is K S plus 1 over S plus 4, and the equation for actuator is 1 over S plus S power of 2 plus 6S plus 8. Next, we cascade both part and simplify the equation. So the new equation for the system is K S plus 1 over S plus 4 plus S plus 4 S plus 2. Then we assume K equals to 100, and we change the equation from S domain to J omega domain and simplify the equation. So the simplified equation becomes 25 over 8 times J omega plus 1 over J omega over 4 plus 1, J omega over 4 plus 1, J omega over 2 plus 1. From the equation above, from the previous equation, we separate each part to find the king part and the phase part. Okay, so to find the king part, we need to use the formula which is 20 log kg, magnitude of kg j omega. So the new equation for our gain plot is 20 log magnitude of 25 over 8 plus 20 log magnitude of j omega plus 1 plus 20 log magnitude of 1 over j omega plus 20 log magnitude of j omega over 4 plus 1 plus 20 log j omega over 4 plus 1 plus 20 log j omega over 2 plus 1. Next, we find the phase part. We find the phase part using the same equation as above, but change the formula. So instead of using 20 log magnitude of j omega, we just use the angle of kg j omega. And this is the equation for the phase plot. That's all for me. Thank you.
My name is Siti Nurliza binti SULAIMAN. I will show how to draw a plot using MATLAB. On the left side, we have the full coding. The first 3 lines are not important because it is just to clear everything. This line is the numerator of our transfer function equation, 100s plus 100. This line is the denominator of our equation, s power of 4 plus 10s power of 3 plus 32s power of 2 plus 32s. This line is to represent our transfer function equation in polynomial. This line is to find the gain margin, phase crossover frequency, and gain first over frequency. After we run the coding, we will get our board plot. The gain margin is 6.09. How to find the gain margin? First, we have to find the phase crossover frequency, negative 180, and we will meet the first intersection point. This point is the phase crossover frequency. We extend the line and make this intersection point. From 0 to this intersection point is our gain margin. The phase margin is 25. How to find the phase margin? Quite similar to the gain margin. First, we have to find the gain crossover frequency. From 0, we meet this first intersection point. This point is the gain crossover frequency. We extend the line and meet this intersection point. From negative 180 to this point is the phase margin.
Hi, my name is NURFADZILAH binti MOHAMAD. I will explain about the question B. We decided to design a lead compensator, and there is a step to do the lead compensator. Firstly, we need to find the phase margin and the gain crossover frequency, which is we get from the question A. And the value of phase margin is 25, and the value of gain crossover frequency is equal to 3.31 radian per second. Next, we need to find the phi max using this formula. So, 45 is the required phase margin minus 225, which is current phase margin, and then plus with 15, which is safety margin. So, we get the phi max equal to 35. Then, find the value of alpha using this formula. And then, we know that the phi max is equal to 35. So, we can get the alpha's value equal to 3.695. Later, we need to substitute the alpha value to this formula to get the value of tau, which is 0.157. Lastly, we rewrite the transfer function using the value of tau and the alpha value. That's all for my part.
Assalamualaikum and hi everyone. My name is Nurul NAJIHAH binti RAZELAN. So, I will continue explain the answer for part D. After the calculation that has been done by my friend just now, there is the final system including lead capacitor block diagram. As you can see, this is the lead capacitor gain and the other two are the given gain at the beginning. Then, let me show you the result that we got in Scilab. The first line is to declare S. The second line is the input for numerator. And then at this line, also the input but for denominator. After that, at this line is the transfer function. And then the next line, also the transfer function. And for this line, show the result. As you can see, the value of new phase margin, which is 40.584138. This value is obviously less than 45-degree phase margin as we need. This is because gain crossover frequency also affected from original value 0.527 before. Then GCF new increased to 0.7882822, or after we round off, we get 0.788. So the increasing of GCF is because we use lead capacitor. For your information, the main reason that we choose to design the lead capacitor instead of lag is because a lead capacitor can increase the stability or speed of response of the system. To make it clear, the lead capacitor increases the gain of the system at high frequency. This can increase the crossover frequency, which will help to decrease the rise time and setting time of the system. Thus, the system response becomes faster. That's all from me. Thank you.